All right, so we're going to continue with factoring, but now we're going to factor when a is greater than 1. So the number out in front is going to be something larger than 1, even after we take out any common factors that we have. Now, I'm going to use what we call the Moyes method. So it has another name, but we don't have to worry about the other name. My student Moyes from a few years ago showed this to me, and I felt like this was the easiest method in factoring. Some people teach guess and check, some people teach the box method, some people teach this modified box method where you do factor by grouping. Man, I really like this method. So you can use any method you'd like, but if you've never seen this, I think you'll find this is actually fairly easy, especially once you get used to it. And I think it's a lot faster. It doesn't really take up a lot of space too. All right, so here's what we're going to do. With the Moyes method, first, are there any greatest common factors? There's no number that goes into 8, 2, and 21 evenly, and so no greatest common factors. First step, you're going to take A and multiply it to C. So you're going to take that first term and multiply it to C. I should have brought a calculator, but what you get is x squared minus 2x minus 168. Now, the hard part is finding factoring like normal. So from here, you're going to factor like normal. You have your two sets of parentheses. You know that x times x gets you x squared. Now, you need two numbers that multiply to a negative 168 that at the same time are going to add to a negative 2. So how you would go about this is I would try numbers that are a distance of 2 apart. So for example, like 6 and 8 are a difference of 2 apart. But obviously 6 times 8 does not get you close to negative 168. So what we're going to do is check 12 and 14. So if you would multiply, because 12 and 14 are a distance of 2 apart. So 12 times 14 is 168, but we need one of them to be negative in such a way that when I add them together, I'm going to get a negative 2. So this is going to be a negative 14 and a positive 12. Now that's a large number. You could use a calculator to help you out to just check a few things. So we get x minus 14, x plus 12. So from here, now we found the two numbers that multiply to give me a negative 168, that add together to give me a negative 2. Now, in the beginning of our equation, or in the beginning of our steps, we multiplied by a. We multiplied by 8. Well, that means our equation is unbalanced, right? So we need to get that back to balance. So how do you undo multiplying by 8? Well, you divide by 8. So you're going to divide each constant by 8. Now in your graphing calculator, if you did 14 divided by 8 and hit math, enter, enter, it will give you the reduced fraction. And so what we get reduced fraction-wise is x minus 7 over 4. Over here, when we reduce the fraction, 4 goes into both of these terms, so we get x plus 3 over 2. Now, the final step in the Moyes method, and we are done, is whatever your denominator is, you're going to bring that out in front. And that is the last step, and you are finished. So whatever your denominator is, you're going to bring that out in front. So our final answer is 4x minus 7 times 2x plus 3. We're going to do a couple more examples, of course, just to try to get used to it, because this is probably a new method for most of you. And again, I call it the Moyes method because Moyes was a student that showed me this a few years ago. All right, number 2. First, we're looking for a greatest common factor. We don't have any numbers that go into 8, 47, and 6, but we do have a variable, right? Notice how each term has an x, so we can factor that variable out. And so I have 8x squared minus 47x minus 6. Now, from here, we're going to just look at the trinomial, the 3 terms inside the parentheses. My first step is I'm going to take that number on the outside, and I'm going to multiply that to c. Now I'm going to rewrite what we have. So we have this x times, and we get x squared minus 47x minus 48. So 8 times this negative 6, negative 48. Now you're going to factor like normal. What are, so here's my x, my two sets of parentheses. X times x is going to give me that x squared. I need two numbers, this one's a little easier, that multiply to a negative 48 that at the same time are going to add to a negative 47. Some people always forget about 1 times that number. So please do not forget that. So this is going to be a negative 48 times a positive 1. Negative 48 times positive 1 is going to be negative 48. Negative 48 being combined with a positive 1 gets me to negative 47. So this is the correct way to factor this, or the correct factors that we need to satisfy both situations. But from here, remember, our equation is unbalanced because I multiplied by 8. So to undo that, we need to divide both constants by 8. All right, so now we just have to reduce our fractions. So we have this x on the outside, and we have x minus, now 48 divided by 8 is 6. So x minus 6. So when it reduces all the way and you have no denominator other than 1, that actually makes this a lot easier. Over here, we have a denominator that doesn't reduce, 1 over 8. So we're going to take that 8 and put it out in front. And so our next set of parentheses is going to be 8x plus 1. And that is our answer. So again, I think the Moyes method, it doesn't take a lot of space. You don't have to draw all these charts. You don't have to draw a box. You're not factoring by grouping where you have to worry about a negative in the third term or anything like that. I think it's just a lot easier and it'll work every time. Let's go ahead and just do one more. We're going to get kind of a larger number here. Now, again, look for greatest common factor. Is there a number that goes into 9, 42, and 45 evenly? And the answer is yes. How do you know that quickly? 3, I don't know if you know this, but if you add all the digits up together and that digit is divided by 3, that means the entire number is divisible by 3. So for example, 42 is 4 plus 2, which is 6. Because 6 is divisible by 3, that means 42 is divisible by 3. In the same way, 4 plus 5 is 9, and because 9 is divisible by 3, that means the entire number 45 is divisible by 3. So we can factor out a 3. So we're going to factor out a 3 from each term, and so we're left with 3x squared plus, that is going to be 14, plus 14x, and then plus 15. So factor out a 3, so divide each term by 3, we get 3x squared plus 14x plus 15. Now going into the Moyes method, we're going to write what we have left over. I'm going to take my a term, I'm going to multiply that to my c term. So I have x squared plus 14x plus 45. And now I'm going to factor just like normal. So make my two sets of parentheses where x times x gets me x squared. I need two numbers that multiply to 45 that are going to add to 14. So kind of think about that. Multiply to 45, they're both going to be positive. Add to 14, let me see. 5 goes into that. How many times 5 goes into that? Oh, 9 times. Oh, okay, well 5 plus 9 is 14. And again, the order doesn't matter. You could say plus 5 here, you could say plus 5 here. The order of that does not matter. Now, what do we do to finish this out? Well, we multiplied by 3, meaning our equation's unbalanced. We need to get that back to balance, so we have to divide each constant by 3. So what's going to happen in this first one is this does not reduce. So I'm going to take that denominator and place that out in front. So I get 3 parentheses, put that out in front, 3x plus 5. And then this does reduce. 9 divided by 3 is 3, so I get x plus 3. And then that is our answer. So again, this may be a new method for you of factoring, but one thing I want you to look at is if I have 4 terms, I'm going to factor by grouping. If I have 3 terms, look for the Moyes method. And if I have 2 terms, we're going to factor by difference of squares, or at least look for difference of squares.